Hey guys, so today what we're going to learn about is taking the Lewis structures that you have and figuring out what shape to draw them in. That's something called VSEPR. VSEPR stands for valence shell electron pair repulsion, which sounds really long, but basically it all has to do with electrons, and you know that electrons are negatively charged. You also know that two of the same charges, negative and a negative, are going to repulse or push away from each other. So basically what's happening is all of these electrons are going to push away from one another as far as they can possibly get. When those electrons push away from each other, it gives 3D shapes to the molecules. So it matters the shape that you draw your Lewis structures in after you get the dots and all of the bonds set up. So this is a table that's going to help you figure out what you possibly have. Okay? So if you look, this is all about the central atom. So I would highlight or circle that. You're basically just going to look at what's connected to the atom in the middle. What's around the outside doesn't matter. I just want to know what is stuck on the middle. So if you have either one or two atoms, so one or two bonds stuck on it, and no extra electron pairs, so this one says electron pairs, then your molecule will come out looking like this. It looks like a line because it literally is a linear shape. So I'm going to show you what that means, and you can do this with me in the molecular shapes model that we've got. So here is my center atom. If I add one thing to it, no matter what I do, this molecule will always look like a line. If I don't want to add a single bond, I could also add a double bond, but again, that's still a linear shape. Same thing if I do triple bond. So there's one atom stuck to the center. Got to be a linear shape. If I put two things on the center atom, even if I pull at this molecule, it will still be linear no matter what I do. It looks like a straight line. Same thing if I do double bonds. Even though they're double, my molecule will still be linear no matter how far I try to pull it. That's because the electrons are pushing as far away from each other as possible. So you can actually click down here and it will tell you your shape is linear. So we're going to do an example. We're going to do carbon dioxide and see if we can draw it in a linear shape. So this is what we just learned back on the previous page. If you need a little bit of help, you can go back to that video also. Remember, when we do this, the middle thing is what's listed first. So carbon in the middle, oxygen on each side. Then you're going to want your periodic table. Carbon has 4 valence electrons, oxygen has 6. We're going to put 4 electrons there. 2, 3, 4, 5, 6 on that oxygen. Same thing over here. 6 on this oxygen. Then we're going to connect the lonely dots. So I'm going to connect here and here. And I'm going to connect here and here. And so I know that this is built with double bonds between everything. So if I go back here, this is exactly what this molecule looks like. The purple is the carbon in the middle, and the white or the gray are the oxygens on the outside. No matter what I do, that is a linear shape because it has two things stuck to the center atom, and there are no extra electron dots around it. What that means is when I draw this final copy, I need to draw it in a nice straight linear line with double bonds and with the extra electron dots around it. Okay? What you may not do is draw things like this because that's bent. That no longer looks like a straight line. So if you draw it like that, I'm going to think you don't know what's going on. So make sure that if you decide it is a linear shape, that it looks like a line. But that's not the only possibility. You could also have 2 bonds stuck on there, but you could also have 1 or 2 extra electron pairs. And then the shape no longer looks like a line, then it looks bent. So it's the line that got bent down. So here's what that means. If I go back here, I have a linear shape currently. This lone pair thing is where I can put on electrons. So do you see the teeny tiny dots in there, those yellow things? Those are the dots. When I put them on, that has pushed the bonds away, and now this looks bent. It's no longer a nice neat straight line. It looks like that upside down V shape of a bent molecule. That would be exactly the same if I put single bonds on there. It's still bent. I could do one single and one triple. No matter what I do, I can't pull that molecule into a line. Those electrons up there have messed with it and bent it around. So that's what water looks like. So remember when we do this, usually we would put the first thing listed in the middle, but because it's hydrogen, we're not going to. So we're going to put oxygen in the middle and an H on each side. Hydrogen has 1 valence electron. Oxygen has 6. So now you're ready to put your dots on. So leave the pairs alone and only connect the lonely dots. So if you look at this center atom, it's got 1, 2 bonds. That's this. It also has 1, 2 pairs. That's this. Because of those extra electron pairs, I may not draw this in a line. You must draw this bent in this upside down V shape with the 2 extra electron pairs on top. So you may not draw water like this. That drives me crazy. It is not a linear shape. It must be bent. Okay? Now we've got a couple of other options. Now we're going to start to add some more things. If you have 3 bonds but no pairs of electrons, so no dots around it, then this molecule is called trigonal. The tri means 3, and trigonal planar. Planar means flat. So if you held this molecule in your hand, it would lay flat. It wouldn't stand up or anything. So let's build that in our simulator. Let's get rid of all this other stuff that we don't need. We don't want electron pairs. Go back to the original. So just put 3 bonds on there, like that. And there is your trigonal planar. So see there where it's kind of flat, or if I put it like this, we can kind of make it look like a Y shape. I could also do this with some double bonds. It still looks like that trigonal planar Y shape that is flat. That is what boron trifluoride will look like. So boron will go in the middle because it's listed first. We're going to put some F's around it. Grabbing your periodic table, you'll see that boron has 3 valence electrons and each fluorine has 7. So go ahead and put your dots on. 7 for each fluorine. So these unpaired electrons in the fluorines are the only ones that you can connect. All the other ones that are already paired up you need to leave alone. But what I can do is I can connect all of those to the boron. And now look at this middle atom. Here's the boron. That's the only one you care about. It has 1, 2, 3 bonds coming off of it. That's this. And there are no extra dots on the boron. I don't care about all the dots on the fluorine. I just want to count what's on the boron. That means that I need to draw this in the planar shape, which looks like the letter Y. And then the last thing you have to do is you do have to put all those dots back on the fluorine. You cannot leave them off. Our next option is to keep the 3 bonds on the outside, but then you add 1 pair of electrons. That changes your shape. It's still trigonal because of the 3 bonds that it has, but it's trigonal pyramidal, like a pyramid. So let me show you what that means. I'm going to keep these 3 bonds that I have. I'm going to make them single though, because that's how I like it to look. Okay. There's trigonal planar, it says on the screen, but watch what happens when I add electrons. Those electrons came in and they pushed all of the other bonds away. And so this does end up looking like a pyramid. The electrons are the top of the pyramid, and all of the bonds on the other ends of the atom are like the bottom of the pyramid. That all happened because of that pair of electrons. So we need to draw this in a different shape so that we can tell the difference between pyramidal and planar. Let's do ammonia as an example, and we'll go in the center because it's listed first. You're going to put some H's on each side. Grabbing your periodic table, nitrogen has 5 valence electrons and hydrogen has 1. So I do 1, 2, 3, 4, 5 on the nitrogen, 1 on each hydrogen. Connect the lonely dots, like that. So look at this middle atom, look at the nitrogen. I count 1, 2, 3 bonds connected to it. but I also see an electron pair. Because I see that, I must draw this in the planar, or sorry, in the pyramidal shape, which means I want you to make it look like a pyramid. Nitrogen is the top of the pyramid with its electrons, and then the hydrogen are like the legs of the pyramid, like that. So notice the difference. Planar and pyramidal look very different, so you need to draw them in different shapes. The last option is methane, which will have 4 bonds on the center atom and no dots. This is a shape called tetrahedral. Remember, tetra means 4. That's a prefix that we know. So it's kind of hard to tell, but this almost looks like a plus sign or like an X. That's what the tetrahedral will look like. So if you want to look at your simulator, we want 4 bonds on the center atom like this. And so there's the tetrahedral shape in 3D. And even though it's in 3D, you can kind of see the plus sign that is formed, because I don't know about you, but I'm not very good at drawing in 3D. So we'll make ours look like a plus sign, and then you can kind of think about how this looks when you're rotating it in space in this model. So in methane, I'm going to put carbon in the middle. You know that carbon always has 4 bonds. And now you know that they look like a plus sign because it is tetrahedral. The reason it's tetrahedral is, look at that carbon. There's 1, 2, 3, 4 things attached to it. Those are the 4 bonds. There are 0 dots. There are no other dots connected to that carbon, so it is tetrahedral. So your nice, neat final copy should look like a nice, neat plus sign. That's what the tetrahedral shape looks like. Alright, so now you guys have lots and lots of practice to do. Come and ask me if you need any help.